Okay, last video of this part of sequences and series. Today we're talking about geometric series. Geometric series are the sum of all the items in a geometric sequence. So a sequence, I probably haven't done a great job of defining this. A sequence is just the listing of the individual terms. So like if I were to put a comma behind each one of these, 2, 6, 18, 54, that's a sequence. A series is when we actually put the plus signs in between everything and we actually add everything together. Okay? So today for geometric series, these are not easy to do, up to 8 terms, in order to find every one of them. There are a formula that we can use, and this formula, the derivation of this formula is a little bit harder. It's not as intuitive, so I'm just going to start us off with the formula. And again, this is on your formula sheet. It's on the sheet that I gave you. It's in the IB formula sheet. So the formula is the sum of the first n terms is the first term times r to the nth power minus 1. So raise r to the nth power, find that answer, then subtract the 1. All over r minus 1. It can also be written this way. First term times 1 minus r to the n over 1 minus r. Basically, these two formulas are exactly the same thing. It's just whether or not you're doing it as minus 1 on top and bottom or 1 minus on top and bottom. Now, when you would want to use that is just thinking about which way is going to give you negative numbers and which way is going to give you positive numbers. So if r is, so when I want to use, see if I can pull this thing up, come on now. I want to use this version of it when r is less than 1, because I'll end up with a positive number. I want to use this version of it when r is greater than 1, because I'll end up with a positive number. It really doesn't make a difference which one you use. It's just that sometimes the negatives bog us down and we screw it up on the calculator and things like that. So all to type this out or to work this out is I want the first 8 terms. So S sub 8. I would use the first version. First of all, you need to think about what r is. So in this case, r is, I'm not really sure where to do it over here, okay? 6 divided by 2 is 3. 18 divided by 6 equals 3. 54 divided by 18 equals 3. So our common ratio every time was 3. So first term, 2 times common ratio raised to the 8th power, because n is 8. Then I'll subtract 1 from that. And then all over common ratio minus 1. Now here, the 2 on the top and this would be 2 on the bottom. Those would cancel each other out. So really our answer is just 3 to the 8th power minus 1. Okay? And that answer is, you go to your calculator and work it out. 6,560. So I had to look it up. I do not know that off the top of my head. Okay? So there's our answer. Okay? Let's scroll down, do one more here as an example of this. So here I want to do this to 15 terms. All right? So a little difference on this one. First of all, I would probably start with just finding the common ratio. So negative 3 divided by 6 is negative 1/2. 1 and 1/2 divided by negative 3. Again, you could do that on the calculator. Think of that as 1 point divided by negative 3. You could also write the negative 1/2 as negative 0.5 if you want to. Okay, so there's our common ratio. So now, of my formula choices that I have up here, r was less than 1, so I'm going to use this where it does 1 minus. That way I'll get positives on both top and bottom of the fraction. So I'm going to type it in as, I want 15 terms. So I'm typing in as S sub FINITE equals the first term times the common ratio, which is -1/2 or -0.5, raised to the 15th power. So raise it to the power, then subtract the 1. That order of operations is really important. And then on the bottom, oh, I just did this backwards of the way I just said to do it. So I'm going to back up, and I'm going to do it the way I was saying that I would probably do this, because that's going to give me a negative number. Okay? So I would do this as 1 minus -1/2 to the 15th power. And then on the bottom, 1 minus 1/2. So on the bottom, I'm now going to get positive 3/2 goes to negative 3/2. And my number on the top here will be positive as well. And you will just put that in the calculator. I'd probably do the whole top and then divide it by, do the whole bottom, and that's going to give me something really close to, oh geez, which one is this? It's like 4.00. It's, you know, it's rounded off. And in fact, that's where we should round it to 3 digits in the number, is rounding off the answer. Okay? Last one, just to show what this thing is asking. In number 2, it just says find the formula for it. You don't even have to type it in the calculator. Okay, you just have to give me like this basic strategy right there for it. So to start with, we need to figure out our common. 3 divided by the square root of 3 equals. Okay, that one may not be as easy to do, so maybe I come over to the next one. Square root of 3 divided by 3. Those just cancel out, and I get square root of 3. So there's my common ratio. If I were to do this, remember that we learned this in previous classes, that one of the things I do is I multiply top and bottom by the square root on the bottom in order to rationalize this. And I would get 3 square root 3 over, and square root 3 times square root 3 is 3. And then those would cancel out. And there's my answer, square root of 3. So my common ratio is the square root of 3. So my answer here, my formula for the sum of the terms, would be first term, which is square root of 3, times, I'm going to do my common ratio, which is also square root of 3, raised to the n, minus 1, over square root of 3 minus 1. And these answers, you know, no matter what the nth term is, these are going to get really kind of ugly in terms of the sum. And so that's why one of the things you're doing here is just, can you tell me what the formula is? So on this problem, you're just done right here, and you don't actually have to go to the calculator to work it out. Okay? On this sheet, the last one, number 3 is kind of like a challenge problem, so I'm not really going to talk about it. I'm just going to see if you can kind of work it out and figure it out. It helps work as a transition into why sequences and series, why we care about them, and how they apply to maybe some real life things later on. And so give that a try. I'll walk through it at some point whenever we go over all this homework. Okay? So you need to finish all the rest on the page, and that is it for sequences and series. Everything else that we do will just be practice. Good luck, and please reach out if you have questions.